Hello, welcome to Designs for the Edge, our latest live stream series from Microchip Technology. In Designs for the Edge, we talk about market trends and system design challenges. We are live streaming today. Please subscribe to the channel, like the episode, and feel free to ask questions, and we'll try to get to those at the end of the episode. I'm your host, Eric Glatfelter. Our topic today is implementing optimal security for data centers. Joining me in the studio is Todd Slack. Todd, welcome.
Thank you, Eric. Pleasure to be here.
For our viewers, would you describe your role at Microchip Technology?
Absolutely. I'm the product line manager lead within a business unit totally focused on secure products. We're called the Secure Computing Group.
Okay, thanks. So let's dive into our topic. Let's kind of set the stage on the market here. Lots of things going on, more and more devices being connected and doing computing, a lot of them on the edge, but a lot of that data finds its way to data centers. And obviously, lots of discussion in the world about AI and increasing the need for data centers. So what is driving the discussion about security specifically within data centers?
Well, you know, I have a lot of conversations surrounding security topics, being from a security business unit.
Yep.
I tend to start the conversation very similar fashion, is that there's just no shortage of attacks that are out there.
Okay.
You have all these connected devices connecting back to a cloud. You have AI generating a lot of hot topics here, allowing new use cases. We used to see a number of attacks more focused on the application layer in the OS. We've seen those move down to hardware, firmware,
Okay.
really getting down to the root. If you have an attack there, you're talking about unauthorized firmware, which could leak personal information. Maybe it's corporate IP. You're really turning into liability situations when you compromise the firmware. So if we look at kind of the trajectory here, Microsoft had this percentage that 83% of all businesses have been impacted by some hack on firmware. Okay. That's a big number. And then you correlate that to dollars. Is that now IBM says that the average expense to a company when you're exposed to that type of firmware attack is $4.88 million. So it costs real dollars.
Real money.
Yep.
Okay. Okay. So it sounds like you're also saying that there are an increasing number of types of attack, and within each type there's an increasing frequency of attacks across the industry. For sure. Okay.
For sure. A lot going on. So with the different types of attacks, we see a response in the industry, coming from National Institute of Standards and Technology, or NIST. They put out these specifications. In the data center space, you have this platform resiliency specification, which is SP800-193. You start to know all the lingo and numbers with these specs. But they are pushing requirements, best practices out to say that you need to have a hardware root of trust. This is not really something that you should be implementing in software.
Okay.
Software can be capable of handling data, but it can't protect the data. Mm-hmm. So we really focus within NIST on hardware root of trust. This means that you start off with things like an immutable bootloader. You can guarantee how that operation is going to kind of come up. With that, they also moved the crypto requirements from elliptic curve cryptography, ECC P256 to P384. So as we look at the requirements coming from NIST, similar requirements from the Open Compute Project, now Microchip has solutions for that in that space, really for our embedded controllers family. So with the CEC 17.3X, namely the 1736 these days, but we also have the 1734. We really are the first thing to boot up on the platform.
Okay.
And we control the reset line for the host controller. We verify that firmware that's about to be loaded in the host is in a trusted state. We're compliant to CNSA requirements for Suite 1.0. We get all of our algorithms certified for FIPS, cryptographic algorithm verification program, and so we've got all of our customers covered,
right.
So that they can kind of check the box in hardware to satisfy these specs.
Okay, so with these requirements from the industry and the industry responses, and some of the solutions that we have from Microchip, how would you think about, when you think about the ecosystem of the data center, categorizing the different types of security and the different types of solution for them?
Yeah, so data center has really been focused on the host platform for quite a while. So When you look at the host platforms with CPUs, management controllers, the BMCs, we have our embedded controllers there. It's been kind of mature, even though it's evolved from generation to generation. Now we've seen this expansion into peripherals.
Right.
You know, so we have these DC SCMs, these secure control modules within data center, these add-on cards, NIC cards, power supplies. We're adding all sorts of advancements here with more and more hardware that you should care about the security equally as you did on the host.
Okay.
So we've seen it expand.
So are the challenges different for peripherals than they are on the host, and are the solutions different than they are on the host?
The solutions are slightly different. There's a little bit of an overlap, but basically what we are focused on is to say that we have the right solution for the right component. So we have embedded controllers for the host. That's your most typical. And then we have some other devices, which I'll show you an example here in a second, from our secure element family that satisfy the peripherals. But you know, the real challenge for our customer base has been that not every one of them has deep knowledge of security.
Sure.
So they get these standards and they say, I want to satisfy the standard. How do I get started?
So that was having the same thought, right? That there's a lot to understand there. These are very complex ecosystems. So for somebody who's thinking about applying, you know, the best ways to apply security to the different pieces of the data center, how would you know, how do they get started? How do they navigate through that process?
Yep. So we have the Trust Platform Design Suite. So we know those use cases. We know how that maps to a specific function within a device, a piece of hardware, and we can kind of take our customers on that journey through this easy drop-down menu on our configurator with TPDS.
Okay, all right. So am I interpreting that correctly? Is you can come into the tool and give the tool a little bit of information at a system level, and it'll help you sort of navigate down to the more detailed level.
That's right. And we have that with a number of our devices, and in fact here to kind of come to our peripheral expansion on that discussion is that, you know, when we move from the host platform to some of the peripherals, we do see a little bit different architecture, but that journey through TPDS is the same. So here we have an example of power supply authentication. So there's this specification for power supplies that you need to have attestation of the firmware, secure boot. You need to protect your keys in order to prove your identity with signature capability. And so now we shift a little bit gears here on some of these smaller resourced or lower horsepower platforms that are perfectly well served by a microcontroller. And so we have this project with power supply authentication with our MCU 16-bit family with a DSPIC 33, coupled with a secure element, which is our Trust Anchor 100, where we satisfy all of these hardware attestation requirements.
Okay, so what does an actual implementation flow look like when you get it down to a particular security solution?
Yeah, so the Trust Platform Design Suite really is the aid in that whole process. And so with TPDS, again, it simplifies things for our customers. You can look at things in terms of a use case, so it's not getting down into the bits and bytes of the algorithms. We do that for you. We have that done in hardware. So you can choose things like, I need secure boot. Well, that satisfies a NIST requirement. That satisfies an OCP requirement. I need secure firmware update, transfer of ownership, all sorts of these things where you can kind of click these menus, and then we help you configure the devices with that. So the end result is you get a device with configured OTP, certificates. Basically, the provisioning whole process is done within our tools and our certified facility. So from a proto point of view, we have development kits where engineers can play, so to speak, and use a proto-configured device to allow them to configure, reconfigure, and kind of, again, just experiment during the engineering phase. Okay. Once we move from prototype to production, now we are moving away from the proto units into production units, which is really lifecycle management within this whole data center community and their specifications. At that point, you know, once you're happy with the configuration, you can lock it down, and now Microchip has secure provisioning facilities to start cranking out hundreds of thousands and millions of devices,
Right.
each with custom sets of keys.
Okay. Now, the Secure Provisioning Facility certification is a non-trivial exercise, correct? Can you tell us a little bit more about that?
It is non-trivial. So it's nice for us to say that we do something secure, and we feel that we do. But really, it's important to rely on third parties.
Sure.
So the common criteria ecosystem is really globally recognized methods to use accredited labs to come in and use very standardized auditing processes to verify that you have a secure facility.
Yep.
And so we have been audited by an accredited lab. We have these certifications posted publicly.
Sure.
And so we have been certified to the highest level that you can get, which is ALC_DVS.2. All sorts of acronyms for you. But yeah, we have truly secure facilities.
Excellent. All right. So it sounds like you start with the tool at a very high level, and you can get all the way to production units securely manufactured. So awesome.
Absolutely.
Todd, thank you so much for that overview. Let's pause there. I will go to our live stream feeds and see if we have questions from our viewers today. We do have a couple. So the first one is, so where can I find more information about CEC173X family and the TPDS configurator?
Very good. So we do have secure methods to basically exchange information. So you should go to My Microchip and sign up, create an account if you don't already have one. And then within the My Microchip account, you can opt into this extension for our Secure Document Extranet, or SDE. The cool thing about SDE is that if you opt into updates, say we give you access to the CEC173X family datasheet,
Yep.
and we push out a new datasheet, you would automatically get notified via email that, hey, there's a new datasheet. So
Okay.
we don't have to remember, you don't have to look back every couple months.
Checking.
You just automatically see it.
Gets pushed to you. Okay, great. So a little bit more about the CEC173X. Does that device support OCP and TCG attestation?
TCG, yes. So OCP we've talked about.
Yep.
We do support that for attestation. And then we also support the TCG, which is the Trusted Computing Group. They have their DICE specification for attestation, and our hardware supports both. So
Okay.
you're perfectly welcome to follow OCP or TCG DICE.
Okay. Last question, I think, is can I purchase blank parts and provision them in our factory?
Haha. So, we've had this discussion over the years with many different devices, whether it's a secure element or an embedded controller. And I think that some say, well, I'm just going to do it in-house. I know a guy in my company that can provision devices, and he has access to this PC that can generate keys.
Yep.
That is not a secure facility. There are specifications and a real push for making sure that your supply chain is secure these days.
Sure.
And so, shipping devices out with JTAG enabled that aren't locked down is a real security concern.
Sure.
And so we highly recommend that you don't do that and that you really remain compliant to the best practices by NIST to have Microchip do it in a secure facility that's been certified, as we talked about before.
Okay. All right. Todd, that's our last question, so we'll wrap up. I want to thank you again. I want to thank our audience for taking some time out of your day to join our discussion. As I said, this is our second season of Designs for the Edge. This is the first episode of the second season. We'll be doing a live stream every week at the same time for the next 6 weeks through October 16th. So please join us again. For more information, visit microchip.com/designsfortheedge. There you can see our calendar of upcoming episodes. Subscribe for subscriptions and notifications. So I hope you enjoyed the episode, and we hope to see you next time. Thank you.